Hello there. Today I want to talk about software design principles, and instead of rambling on for hours before I get to the point, let's just get right into it. There are 5 of them that I'd like to cover, and the first one is the single responsibility principle. It means that you and you alone are responsible for the software you put out into the world and the bugs in it. Like you can understand the entire system. Bugs are hardly ever the runtimes or the compiler's fault, it's your fault. You are the single person responsible for all the bugs and the problems. Since there is no magic in the entire stack of the computer, and the defining feature of computers is that they do what you tell them to do pretty much exactly, it means that you are responsible. You are at fault if something goes wrong. And that's the first thing you have to accept with computers. You are the single person responsible. And that's empowering, because that means that you can understand it all. It means that computers don't discriminate. If someone else can do it, so can you. Now, for the second principle, it's the open-close principle. That one is rather easy. It means if it takes more than a second to open or close your application, or a project, or a document, or whatever it is that your application actually is designed to work on, you're doing it wrong. There are exceptions to this, of course, but they don't apply to you, usually. It's easy, just don't make users wait. And that begins with starting and closing, opening and closing your program, opening and closing a document. The next one, that's an important one. The Liskov substitution principle. Ask yourself, what would happen if today someone orders of magnitude more intelligent than you, maybe someone like Barbara Liskov or Donald Knuth, was substituting for you, just for a day? What would they do? Would they be ashamed of what you have created? Why? I mean, they pretty much sure they would be ashamed of what you have created. So figure out why. And then I guess the next question would be, how long would it take them to compile your program to actually get to the point where they are annoyed? So these are important questions. Just ask yourself, what would Barbara Liskov do given my program? Just think about what would somebody who's smarter than me do. That's the Liskov substitution principle. The interface segregation principle. So that one just means, can you segregate the parts of your program that actually need to have a public interface from everything else? In the end, most of your code should be optimized for deletability first and foremost. And the easiest way to not break any dependence when you do that is to not have any. Ask yourself, does this thing I'm creating really need to be public? Or can you segregate it from this interface of what you're providing? It means copy code instead of prematurely creating a helper function. Delete all those things that seem like helpful for a potential user, but don't actually have anything to do with the service your software provides. Your GUI library, for example, just does not need to have a convenience function for reading files from disks. That's not what you're doing. Maybe internally you still have that function, but there's no reason to keep it in the interface. Segregate it from the interface. And now on to the last one, the dependency inversion principle. When you write a library, don't just think about the things you depend on. Instead, invert your thinking and consider those poor souls that will depend on your work. Will they curse when they try to compile a local version because your code isn't self-contained? Can you make a single header file version instead? Does your library ask them to buy into a huge framework that they never asked for just to solve a simple problem? Make your library spark joy, because we both know that your dependencies usually don't. So there's a simple acronym to remember them all, and that is stumbling over long interface definitions. Software development is mostly just stumbling over long interface definitions. You all know it, you read the manual, you stumble over a long interface definition, and the shorthand for that is, of course, SOLID. So these are the 5 SOLID principles for good software development. I hope it helped. Please do share your opinions. I'm curious to hear what you think.